Our story begins billions of years ago. Imagine a vast cloud of gas and dust. This cloud, a nebula, drifted through the cosmos. It was filled with the remnants of dead stars. These remnants held the ingredients for planets, for life itself. This cloud was where our Earth would be born. The nebula wasn't static. A force acted upon it, pulling it inward. This force was gravity, the sculptor of stars and planets. As gravity pulled, the cloud began to collapse. It spun faster and faster, a cosmic dance of creation. This collapse wasn't uniform. The center, denser and hotter, became the focal point. Material rushed inward, drawn by gravity's relentless pull. The cloud, once calm, was now a swirling vortex of cosmic matter. At the heart of the swirling cloud, a star was being born. The pressure and heat at the center became unimaginable. Atoms, once separate, were forced together. This fusion, the merging of atoms, released incredible energy. Our sun, a giant ball of burning hydrogen, ignited. Light and heat erupted from this newborn star. The solar system, once dark, was bathed in the sun's glow. But the story wasn't over. While the sun blazed at the center, the remaining material continued to circle. This material, a disk of gas and dust, orbited the sun. It held the seeds of planets, waiting to be formed. This disk wasn't uniform. It swirled and churned, particles colliding with each other. Some particles stuck together, growing larger. The process, slow and chaotic, was the first step in planet formation. Within the swirling disk, dust grains collided. These collisions, initially gentle, became more frequent and forceful. The dust grains, bound by static electricity, began to clump together. These clumps, called planetesimals, were the building blocks of planets. As planetesimals zipped through the disk, their gravity attracted more particles. They grew larger, some reaching hundreds of kilometers across. These larger bodies, called protoplanets, exerted even stronger gravitational pull. One such protoplanet formed in a special region. Not too close to the sun, not too far away. This protoplanet would, over eons, become our home, Earth. But its journey was just beginning. It was a hot, molten world, under constant bombardment from the debris of the early solar system. The early Earth was a place of intense heat. The energy from constant impacts, combined with the decay of radioactive elements within its interior, kept Earth in a molten state. This wasn't a solid surface we could imagine. Instead, picture a fiery ocean of molten rock, constantly churning and bubbling. This molten Earth was under constant bombardment. Asteroids, drawn by gravity, slammed into the young planet. These impacts, some colossal in scale, released even more energy, keeping Earth in its molten state. These impacts weren't just destructive, they brought new materials to Earth. Water trapped within asteroids was delivered to the surface. These were the first drops of what would become our oceans. The stage was being set for the transformation of Earth. Section 5, Core and Crust. Deep within the molten Earth, a profound change was occurring. Gravity, relentless and unforgiving, pulled the densest materials towards the center. Iron and nickel, heavier elements, sank towards the core. This sinking wasn't a gentle process. Imagine a planet-sized sphere of molten metal churning and swirling as it descended. This movement adding to the already intense internal furnace of the Earth. As the dense materials sank, lighter materials rose to the surface. These lighter materials, rich in silicon and oxygen, cooled and solidified, forming the Earth's crust. This process, called differentiation, gave Earth its layered structure, a solid crust, a molten mantle and a dense metallic core. This layering was crucial for the development of plate tectonics, volcanoes and the magnetic field, all essential for life as we know it. Section 6. Theia's impact and the Moon's birth. The early solar system was a chaotic place. Planetary orbits hadn't fully stabilized and collisions were common. Earth, still young and evolving, experienced one such collision, an event that would have profound implications for our planet. A Mars-sized object, which we call Theia, collided with Earth. This wasn't a glancing blow, but a cataclysmic impact. The energy released was unimaginable. Oceans of molten rock vaporized and debris was blasted into space. This debris, caught in Earth's gravity, didn't drift away. Instead, it coalesced, clumping together over millions of years. This coalescence formed our moon, a celestial companion that would forever alter Earth's destiny. The moon's gravitational pull stabilized Earth's rotation, creating a more stable climate, and its tidal forces shaped our coastlines. Without the moon, life on Earth, if it had arisen at all, would be very different. Section 7, Oceans form, life arises. As Earth cooled, a remarkable transformation took place. The water vapor, delivered by countless asteroid impacts, began to condense. Rain fell upon the cooling surface, filling the basins created by volcanic activity and asteroid impacts. Oceans, vast and deep, formed on the surface of our planet. These oceans weren't just bodies of water, they were crucibles of life. Within the depths, simple molecules, energized by the sun and volcanic vents, began to interact. Over millions of years, these interactions gave rise to the first simple forms of life. This life, initially microscopic, transformed our planet. Photosynthesis, the process by which organisms convert sunlight into energy, released oxygen into the atmosphere. This oxygen, toxic to early anaerobic life, paved the way for the evolution of more complex oxygen-breathing organisms. The stage was set for the incredible diversity of life that would follow. Section 8. Earth's transformation. From a fiery ball of molten rock to a vibrant planet teeming with life, Earth's journey is a tale of transformation. It's a story of cosmic collisions, volcanic eruptions, and the slow, steady march of evolution. Our planet has known ice ages, where glaciers covered vast swathes of land. It has witnessed the eruption of supervolcanoes spewing ash and gas into the atmosphere, altering the climate for millennia. Through it all, life persisted, adapting and evolving, becoming more diverse and resilient. Continents drifted across the surface, colliding and splitting apart, forming mountains and ocean basins. The very air we breathe, once devoid of oxygen, became rich with the exhalations of countless living organisms. Earth's transformation is a testament to the power of geological and biological forces, shaping and reshaping our planet over eons. Section 9. A cosmic perspective. As we stand on the surface of our planet, gazing up at the night sky, it's easy to forget the vastness of the universe and the extraordinary sequence of events that led to our existence. Earth, a pale blue dot in the vastness of space, is a testament to the power of cosmic forces and the resilience of life. Our planet's story is a reminder that we are part of something much larger than ourselves. We are the product of billions of years of cosmic evolution, shaped by events that unfolded long before our ancestors took their first steps on this planet. As we look to the future, we carry with us the legacy of Earth's epic journey. It is a story of change, of adaptation, and of the interconnectedness of all things. Understanding our planet's past is essential for navigating the challenges of the present and ensuring a future where life continues to thrive on this remarkable planet we call home.